Hello, greetings to everyone. Can you hear me?
Yes, no, no, sir.
Okay, I hope you are doing well, Dr. Maqbool there. So, thank you all for joining. I think it's a very great occasion. So, I welcome everyone to the webinar series hosted by Sinopark Center for Artificial Intelligence. And Dr. Maqbool is a faculty member at our institute. So, with this, I think I will hand over to Dr. Maqbool. So, you can start your presentation, please. Thank you.
Okay, thank you, Dr. Sohail. So I will start. Can you see my screen?
Yes.
Okay, so let's start about the topic today for the seminar, Human AI Teaming for Evolving AI System in Manufacturing. This project is by SCCH as a European project that I joined the last year as a postdoctoral researcher, and I will continue for 1.5 years this project. So there are some facts and figures about the project. It's in Horizon 2020 ICT 38 project. AI for manufacturing is the basic theme. There are 15 partners in the consortium, and it belongs from 8 countries, and the total budget for this project is 5.7 million euro. And is funded by the European Union. And the total duration is 36 months, 3 years, from 2021 January up to 2023. SCCH Software Competence Center Hagenberg, which is a joint collaboration with Sinopark Center for Artificial Intelligence, is the project coordinator for this project. So what's the vision for the human AI teaming platform for maintaining and evolving AI system in manufacturing? The main first basic vision is to overcome the lack of flexibility as a limiting factor of Industry 4.0. The main background is to facilitate it in Industry 4.0, a human AI collaboration team to do work jointly in manufacturing and in the shop floor. So that's the basic first vision. And second is to ensure the role of human being in the future industrial scenario by means of human-centered AI collaboration. Human-centered AI is nowadays a hot topic. How because the main control should be with human. Mostly there is some rumors about AI that AI will replace humans, but now more focus is that the central control should be with human. So this the second vision for this project is to be ensure that human will be the central control person to for the system for all the AI system that installed in manufacturing, because it's evolving with time and new technologies comes, but it will not replace the AI humans. So human AI teaming to close the gap between current situation and the future challenges. As I discussed, the future challenges to adopt the artificial intelligence technologies in the current situation. There is a gap. So we will cover in this project to close, reduce this gap and propose them a proper solution. So current situation is about AI, artificial intelligence, and machine learning system. It's a narrow AI. It's data hungry. They need a lot of data, like big data, and lack of trust. So no one can trust an AI system. Uh, for example, if a doctor have some artificial intelligence system, so mostly they don't believe and trust on the system, but trust on the human. Second is AI ML system engineering, high adoption efforts and AI expert centric, because AI is a new field and more expertise is needed for system engineering. And to reuse, its infancy, because it's in infancy mode currently, and it need more to reuse the current modules or the current system, that we should not go to completely change the current systems. So we will this is the current situation, that we will not replace completely the current system, but we will adopt. The third one is social threats. Uh, Paradigm aims at replacing humans, as discussed. That there is a rumors that AI system will replace the humans, and like there will be no job for human in future because everything will be controlled by robots, and robot will work instead of humans. So there some did not accept this that there is AI system is not a replacement for human. So, so what are the future challenges trained by industry? Because there are a lot of challenges, but in this project is focused for on industry 4.0. So personalization, small lot sizes, and high quality. Because in industry we need high quality products, and there is small lot sizes. For example, we have a lack of data. We don't have some big data that we should predict based on that data. And there is also personalization. Like in human, we have some personal efficiency based on from human to human. So these are a big challenge in industry 4.0. Engineering challenge is to compensate for the lack of reuse workflows, general AI reuse of data and models. That's the second challenge, that we will compensate for the existing workflow. For existing workflow means like currently how we are doing in the shop floor in the manufacturing, to from the idea to the final product. So the whole process, the traditional classical approach or the workflow, that we that it needs to reuse the same workflow in case of general AI, to use the existing data and models, but only to add the AI system. The third one is human-centered AI, human in control, that human should control the overall process, the all system, and technology implementation of human-centered paradigm. So these humans, basically this project is in the scope of human-centered AI, that the control should be in with human, not in system. So a new paradigm of this project is human AI collaboration. So the first is auditable ethics, second is agile development, and third is operational performance. So what means by auditable ethics? The adoption of ethical principle of human autonomy by design. Uh, the same to the autonomy of human, this is the basic principle of ethics to adopt in the AI system. The second is auditable model of trust in human AI interaction based on committed roles and process model. In manufacturing, there is different roles like system engineer, there is operators, control operator, there are workers, so different roles. And there is also process models in the manufacturing. So there should be a model of trust that human and AI can trust with each other. Human trust on AI system and AI system trust in human. It's a big challenge how to adopt, but as this project is the basic initiative for this human AI collaboration. Second is agile development, self-organizing and cross-functional teams of human agents and AI components. As a human, like operators, engineers, and workers, so these are human agents in the team. And in the second side, there is AI components like AI agents. So it also needs software platform like agile AI system engineering and operational. We have agile development in software engineering, so it should be based on self-organization and cross-functional between human, like the human ergonomics, later we will discuss, and the AI agents. Third is operational performance. Like if you have AI system, it should be ease development to develop the AI system and operate it in rich representation of possible knowledge. And also their advanced data analytics in the dynamic manufacturing, because the manufacturing is a dynamic process. So the operational in dynamic manufacturing and also the advanced data analytic techniques should be adopted to in real-time scenarios. So human-centered AI approach. So what's it? What is the basic meaning of human-centered AI approach in modeling teaming intelligence? So there are interdependencies, skills, tasks, and workflows. In the picture, you can see H is the human only activity, because in some scenarios human perform best, but in some cases machine perform best in the activities. So in human there is, for example, leadership, empathize, creator, and judge. This four is the basic activities that human can perform best in the best than machine. On the other side, machine can perform transaction processing. Machine can a billion of transaction process in a 1 second that human cannot perform. Human can just do one activity at a time. And also machine can interact with iterate uh, iterate the processes and also predict based on the data given to the machine, and also adopt some situation like the in workflows and in other AI system. So this machine only activity. In the center there is human and machine hybrid activities that they also need humans and AI human complement machine, like training in humans, or for example if there is a new engineer, so it needs some training on the manufacturing side, and in the industry there is operator worker. If you bring a new operator or worker to the factory, it needs some training and need some explanation. So you will explain the process how it work, and also to sustain to continuously work. And AI gives humans superpower in some process like amplify, interact, and embody. Like amplify, we need like to expand the process. To in expand, AI system can give like scalability, and they can interact the process with each other. And embody, uh, to give some tangible and visible form to it in the process. So this the basic to cover the gap between human and machine. That's the basic theme that human-centered AI approach for this project. That human should be the central, like for example, lead. It should be the leadership should be with human, not with AI system. And in this modeling teaming intelligence, the architecture. So what's the architecture for this project that is designed? Um, the first input there should be static knowledge, like process, how in the industry the manufacturing process are working, and also models, the existing data models, the process model, business models, and teams, like how for one project or one process, how the team is built, and what is the qualities of the team member. Like if you have a task, for example, and you need 5 members for the task to be a team. So one should be the team leader, and the other 4 members will work to achieve a specific goal. So there is static knowledge. For example, you will select the team member based on their experience, their skills, their working experience. So these are basically different policies that should be adopted. So that will be the input to the system. This is static knowledge, because if you have, for example, you have bachelor degree for an engineer, it's a static knowledge that the worker, the engineer should be a graduate. And secondly, if you have need some worker, it should need he need must be 3 or 4 years work experience. So this static knowledge and dynamic knowledge or dynamic data is from sensor, from logging and contextual information from the system. So these two are the main inputs to the knowledge graph engine. KG means the knowledge graph. So self-diagnosis, KG, reasoning on events and contextual. There are complex event agents like filtering, aggregate the data, and monitoring agent, for example, virtual sensor, and also runtime knowledge graph. This is a lightweight knowledge graph, for example, low latency that can execute in real time. Still currently working on this scenario for the runtime knowledge graph have some challenges. And the action is the decision support system. Uh, for example, engineer and operator. So that's what the human centered, that the decisions should be taken by the engineer or by the operator. It means that it should be a human. And there is optimization and control agent. For example, the AI system can give you suggestion to the process about the process, and operator or engineer can just give them answer from you, yes or no, that this is okay, this configuration for a system is okay, and let's continue. Or should be if there is some hazard or some dangerous things coming to happen. So the engineer should monitor an operator, and it could stop the process that it's not going well. So that will be the action recommended or predicted action from the knowledge graph engine. So that's the basic overall architecture of the system. The knowledge graph engine should be the input in the software platform for human AI teaming. It's a little more detailed architecture of the system. On the top is there in machine learning and industrial IoT. And first is model building block one, and the second is construction of knowledge graph. Third one is learning, the third building block, and the final one is the engine, the teaming platform, AI teaming platform engine. So in human AI teaming levels, there are cross-functional teaming, trustful cross-fun, what we saw about the trust model, and agile AI development. These are in the human, in the graph, knowledge graph, take input from this human AI teaming levels, cross-functional teaming, and also manufacturing model. There is trust model, ethics and policies, adaptable graph embedding, and changing context. And this teaming.ai engine extend the narrow AI. So it will integrated with human intelligence and integrated context according to the environment. Uh, and what's the basic output? That it increased overall labor effectiveness, OLE, and also OEE, overall equipment effectiveness, like agile production, decision support, digital twin, quality control, process diagnostics, and large part manufacturing. We have 3 use cases for this. Later we will see it. And this project is divided in total 9 packages. For WP1 is the work packages. And the first level, currently we are in the work package number 3 and 4 is working, and P5 and P6, and the final is about P9. It's not mentioned here. So the current status is about the KG engine for manufacturing is at the technical readiness level at 3 and 4, and expected to be finished in next month up to 5. Um, There is a modeling of human AI interaction processes, and also there is recommender system for a goal-based composition workflow engine. And the final is integrated self-diagnosis. Self-diagnosis is a policy constraint workflow. And also there is about the trust modeling that should validate the test scenario with respect to correctness and compliance violation. So these are some current status. Maybe it's a little technical, but let's go to the next. Modeling, how to model the teaming intelligence. like the overall teaming intelligence. So in static knowledge is in the architecture, I explained there are roles like the engineer, operator, and worker, and all the rules that are working in the manufacturing and the factory. There are skills, interdependencies, like how one person or one operator can depend on the engineer. It should take some orders from the engineer or need some approval from the engineer. And also there is process. So the core, the dynamics, the central dynamics is like the team leadership. And also there is mental performance monitoring. The first P1, the package, and the second backup behavior, and we use for the knowledge is the shared mental models for adaptability and team effectiveness. So these are a closed loop communication, and also to sustain mutual trust. And the action is to perform some uh, process or some task collaboratively with human and AI system. There is a big five in teamwork research paper that is model based on these big five. So activity interdependency analysis, this just example like human team. We have operator role 1, operator role 2, role 3, and there are some tools that are in the factory like machines, some assemblies, and the teaming AI platform. So activity, for example, if we have one activity, activity 2, 3, and there are sub activities, so this will be which operator can perform this activity according to the skills, knowledge, and their in his qualification, and which tools and machine are used, and what are the teaming AI platform responsibility. For example, diagnostics, it's take some decision. If the operator needs some decision from the AI platform, it will give input based on some internal analysis. So these are the analysis to how interdependently work human with AI systems. And modeling of the trust cycle, how to the trust between human and the AI system. According to the situation awareness, for example, if one operator or one worker is working, there should be to monitor their process if there is some hazard process that is expected, so it will give some alarms to predict that process. So uh, in the main is assurance level to use the share mental models and based on transparency to do the process, and also the time pressure and number of entities. For example, if we have 10 activities or 10 processes, so that will collectively which operator work is fit according to this activity, and which AI system is needed, and which tool and machine is needed for this process. So this will first define, give input all this to the knowledge graph engine. So share mental models. Basically, in this project, I am also working on the share mental model (SMM). There is a good book if someone want to more interested to read Thinking in System and Mental Models by Marcus P. Dawson. Generally is not a card based on this project, but it have a lot of different ideas for how the systems work using mental models. So mental model is basically a representation of human mind's thought processes. In simple words, if I can define what is mental model is like if you think something about, for example, I take example of this workshop. If you saw for the first time the ad or the banner for this um, webinar, that there is a human AI teaming webinar. So what comes to your mind? That's the basic mental model, that you have some idea. For example, if you hear about PFIST or SCC SCH or any. So there is some related experience you saw. For example, you heard before about the SCCH. So you have a mental model that it has a collaboration with SPCAI and also PFIST, and someone is working there, or and another example is, for example, if you hear about America, so how what actually comes to your mind? There is some related knowledge that you have according to that word that is connected with that idea. Similarly, if you have some sport activity, for example, cricket, like for example, the president of Pakistan, Imran Khan, if you know, just hear the name of Imran Khan, there automatically comes to your mind that he was a character. He was best in cricket at his time. He won the World Cup. So that's what the mental model that created that have whole knowledge. So this is basically come like the Google that constructed the knowledge graph. When you give to some one word or one sentence to the Google search engine, behind this process there is a knowledge graph that extract all this knowledge and present you in a proper way, like in different ones. So that's what that mental model works. And the share mental model is organizing knowledge to structure relationship, like or to relate one process or one words with others, and one different, like in teaming we have the human and the AI system. So we will construct a share mental models, like if one member in team is working, it has some mental model about the other operator or the engineer. What will be if I do this action? What will be the response from the other member or from my team leader? So that's called the mental model. So we will organize this knowledge in a share mental model, uh, and how we understand the world. In these books, according to this book, the definition is from this book, mental models are how we understand the world. Not only do they shape what we think and how we understand the situation, but they drive our decision and feelings. So they're basically they are connected with each other. All the whole world, the scenarios, the processes, and the activities that are connected with the human mind. Basically, it's according to the mind thought process. So in this project, SMM refer to the overlapping mental representation of knowledge by members of team. So all the team members that will perform in human AI teaming, that will there in the previous slide that we have some overlapping, the hybrid activities that should perform by human and AI. So that will be covered by using shared mental models. Okay, so now let's go to the knowledge graph engine. Uh, that was what we discussed was the input to the knowledge graph engine. So in oh, we learning from knowledge graphs, all the process. Knowledge graph was basically developed by Google, and now it is used in many AI system. So what's the knowledge graph embedding? We map all this knowledge into a vector space. We we have a graph. There is vertices and there are relationship between vertices, so which cause triplets. So we have triplets, and then we convert all these triplet to vector form, the vector features, and then in this vector we apply some the machine learning and deep learning, the hidden layer, and give some output from this knowledge graph. For example, if you submit a query to the Google, the knowledge graph will return you a knowledge, a different web pages where they find the relationship with your query. So that's the basic scenario from the knowledge graph. And knowledge graph on the web, there is some more interesting papers if someone interested. OpenK and Open Toolkit for knowledge embedding. Knowledge embedding is like to mapping in the knowledge into vector spaces. So key challenges, what are the challenges? Scalability and dynamics challenges for the knowledge graph. Most knowledge graph in it designed for static knowledge. Currently, according in the research, the knowledge graph embedding are designed for static, but the knowledge graph will change over time, and retraining embedding on the whole knowledge graph is every time or very time consuming, because when the knowledge, the input is increased, so the knowledge graph will be increasing, and its computation and its searching takes more time. So for the approach that adopted in this project is lightweight knowledge graph and embedding in by the Paul Him uh, paper in lightweight approach for the knowledge graph embedding. The paper link is in the given link and below. So there is also alternative random walk strategies that can be used. For more detail, you can read this paper, how the lightweight knowledge graph and embedding is used. So this is the approach that adopted in this human AI teaming. So the next is software platform for human AI teaming. What's the output of this project is a software platform for human AI teaming. So the teaming model is a high level perspective on teaming is one is development like the teaming model, and there is all ops teaming engine, that is the blueprint between constraint to share data and knowledge between development and operations, and the teaming process analysis. And orchestration is self-adopting production system, that the system AI system should work in runtime processes, and the monitoring and escalation should be also scalable and working in real time when there is the manufacturing side that there is working on some processes. So the teaming AI architecture is a little more the teaming model engine that dynamic knowledge graph act as a single integrated data store. It's like a data store, basically the knowledge graph. And also the teaming engine is connected with the static knowledge that is input to the system, and digital semantic shadow of the production system for all software components. So it will capture all the um, components into the teaming engine, and it will observe, and there is also monitoring agent which for example monitor the workshop floor that there is some process that work is not going well. And knowledge graph runtime, it's connected and also with the machine learning and decision support system, and there is also HMI human machine for operators, machine operator, and also for the engineer, there is some specific interfaces designed for it. So what are the use cases for this where should be implemented for experimental base? In this project, there are three use cases. One is with a Turkey company called FarPlus, and the second is Spanish company from Spain, Industrias Alegre, and the third is Goemix, also a Spanish company. So these are the part of our consortium. The first FAR Plus have the transfer learning based on robust quality inspection for the plastic injection molding machines. And the second one is also most similar, but a little uh, different from the first one is machine diagnostic for plastic injection. It's also on molding machine to improve the quality and reduce the waste on the shop floor. The third one is Goimek is a little different. It's about the ergonomics and a risk prevention in large part in manufacturing. Let's have a basic overview of these use cases. So for the FAR Plus, the first one is quality inspection. What are the goal? The goal is automation of vision-based quality inspection tool that can be improved through the operator feedback. For example, what these manufacturing company are doing, they their products are like the parts for cars and for vehicles. They produce using injection molding machine. So there are a vision automatic system that will detect if the product is good quality or bad quality. So the operator want to look at the product, the final output product from the system, and if it is not good, he will reject the product, and there the engineer will give some different configuration. For example, if the quality is not good or there is some there is some pore or something scratches, so they will find, the engineer will find why this quality is not good. So they will check the system, and also sometime the materials, the ingredients, they will check like the chemical. If the quality is not good, they will have some test. So in teaming AI, the fault analysis decision support, it should be an AI based, like there will be a vision system using capture the picture of the product, and by using image processing, that will detect there is some fault or not. And the human control will verify this process, this injection machine process, the product of the final product, to check the quality. If the quality is good, the operator will accept, okay, this is a good quality. So this feedback will be stored, and this will be a looping process to repeat for all the products. So the quality will be automatically uh, checked by the system, and the operator, the human, will be the center control to only verify that is the product is good or bad, based on the suggested AI system. Use case 2 is a machine diagnostic, is also injection molding machine process, self-adjustment of process quality parameters based on process diagnostic and operator feedback. So the same as in the use case 1, if the operator give that this product is good, the quality is good and accepted, so the system will store that parameter and that configuration. Uh, and if there is some bad product, and then machine will store that parameter and configuration of that bed product, and will self adjust the process parameter according to the good quality. So there is quality check and also the injection parameter optimization for the injection molding machines. The third one is use case is ergonomic risk prevention, like the to assess the ergonomic risk and predict which sequences of action are ergonomically favorable in for humans. Like these are big parts. Maybe if it's they have dangerous for a human, if there is some mistake done during moving from one place to another. So there is some production in teaming AI tasks. There is fine-grained production process documentation, like that will have different parameter about the weight, the size of the product. And also there is ergonomic risk assessment. It's basically more from the psychology point of view. There are some models that are developed, but is overall high-level overview in this slide. So there will set up the machine state and also the operator feedback, like the operator, if the weight of the part is so heavy that that human or the worker cannot take it. So the operator will know that this is not done by human, and it needs some like crane or crane to take to replace or relocate from one place to another. And there is also tracking and scene analysis system, like there is camera to control the overall activities. And it's in milling machines, in the manufacturing in milling machine to uh, produce these huge and big products. So basically it's from the ergonomic risk prevention. If you don't know what is by ergonomics, is about the science concerned with jobs or tasks done by physical and mental capabilities of the worker, like the worker, the human can do this or not. If there is heavy weight or something to that the human worker cannot do it, so this is called a risk analysis. Okay, thank you, and stay connected with us. This is there is some more information on the teamingaiproject.eu website, and you can also contact with me on my more information is on my website. maqboolkhan.com. So any question from your side? Let's. Anyone have a question?
Yes, sir, I have a question.
Yes, Doctor.
Sir, you have talked about the ethics, the people trust and the AI. So, what are the measures you are taking in this project to improve the trust of the end users?
Yes, ethics is the basic main part of this project that will be developed, and the final, the ergonomics, the last third use case is more about the trust. Like the if the in use case 3, if the worker cannot move the huge part, and it uh, should be depend on the system or the crane or the system that will move. So if the machine or the engineer or cannot trust on the worker that it will not do, so it will suggest the system. And similarly, the suggest the AI system will give some prediction that this part is not, or this process or this task is not done by human. So the human and AI system will have more trust on each other if the AI system suggests to the human that this process or this task is not, this activity is not done by human, so it will suggest to do by alternative by the system. And human will also need to develop a trust on the AI system that what the system suggested to me is basically the risk analysis is better for human, like for me it's better. So that's the trust that will build between human and AI system. Is that clear, Dr. Akhtar?
Yes, sir. Thank you.
Okay, thank you very much, Dr. Maqbool. It was a nice presentation.
Thank you, sir.
Yes, okay. So maybe I would like to ask audience if they have any further questions, please feel free to ask. Otherwise, what we can do is we can go through the list of attendees and we can ask them if they could introduce us themselves and if they have any question or they could give you feedback. So maybe we
Yeah.
can go itemized
Yes, sir.
wise. So Miss Avoha Ruhi, can you hear us, Ruhi, Miss Ruhi? Would you like to introduce yourself or give some feedback? Ahoha, are you there?
Maybe she's not
Okay.
listening, or sometime
Okay.
there is internet problem in Pakistan.
We can go to the next participant, Aksa Khan. Aksa, do you have any feedback? Could you please also introduce yourself? Okay, Aksa, can you hear us? Okay, Aksa cannot hear us either. Arshad Iqbal, I think Arshad, we already know Arshad. Avas, we already know Avas. Mr. Bilawal Khan Jadoon. Bilawal, can you hear us?
Sir, actually, these are our MS students, most of them. So
Yes, yes, I.
maybe they are a
Uh,
bit shy. So I will encourage them to ask any question that you have.
yeah, I think Muhammad Ahmad is also will work on the same. This is my first project, and the second project about predictive maintenance. Muhammad Ahmad, and there is Isra Zafat, and Bilal also
Yeah,
will work.
let's still try to somehow encourage them to speak. Let's
Yes.
go to the next participant, Miss Hamna Shokat. Hamna, can you hear me?
Assalamu alaikum, sir.
Ji,
Yes.
walaikum
Walaikum
assalam.
salam.
Sir, should I
Isra,
be?
please. Would you
Assalamu
kindly
alaikum, sir. And
introduce yourself, Isra?
Yes, sir. Sir, I am Mr. Safat and doing MS from here, Park Austria University. And also I am doing work with Dr. Maqbool.
Okay, excellent. Good. So any comment, Isra?
Sir, very good presentation. It was informative.
Okay. Thank you very much. If you have any question, please feel free to ask as well.
Sorry sir, अस्सलाम वालेकुम.
जी वालेकुम अस्सलाम बिलावल.
जी सर, वो एंट्री का थोड़ा इश्यू था, इसलिए शायद आपको आवाज़ नहीं आई. बार बार ट्राई कर रहा था.
जी please introduce yourself, Bilawal.
Well sir, I am Bilawal Khan Jadoon. My bachelor degree is from Comstate University in Telecommunication and Networking. Now I am currently doing my MS in Artificial Intelligence. और सर से हमारी मीटिंग पहले भी हो चुकी है. हमें इसके बारे में सर ने पहले भी काफ़ी कुछ बताया था, हमें काफ़ी इन्फॉर्मेशन थी. तो जो आज उन्होंने फिर इसको थोड़ा डिटेल में डिफ़ाइन किया, तो वो चीज़ें अच्छी तरह जो है माइंड में बैठती गई हैं. और माशाल्लाह अच्छी प्रेजेंटेशन थी, समझ भी आई है हर चीज़ की.
चलें, बहुत शुक्रिया बिलावल. Thank you very much for your time.
Thank you.
Okay, we have a new participant, Miss Ariba Nakwi. Ariba, can you hear us? I think Ariba cannot speak because her mic icon is somehow disabled. Anyway, Ariba, if you hear us and if you want to comment, please feel free to do so.
Yes, Assalamu alaikum, sir. I can hear you.
Ji, please, Ariba, would you like to introduce yourself?
First semester. Yeah, I'm introducing myself, sir. I am Ariba Nakwi. Studying in PEP IST, and currently I am doing chemical engineering and I'm in third semester. And by the way, artificial intelligence, I like it and I have a lot of interest in this because it's the demand of our time right now, and we should have the knowledge about it. And it was a great seminar today, and I learned a lot because it is not related to my field, so that's why I learned many new things today. Thank you.
Okay, thank you very much, Ariba. Thanks for the nice feedback. So, okay, next in line is Hamza. Hamza, can you hear me? If you have any comment. Okay, maybe Hamza is not able to hear. Maria Bibi. Actually, your guys' feedback is very important because based on this feedback, we can try to improve our future sessions. So if you have any feedback related to this seminar or in any general feedback, that would be most welcome. Muhammad Aftab. Aftab, can you hear me? Muhammad Ahmad Khan.
हेलो
जी मारिया प्लीज.
जी सर, बहुत अच्छा सेमिनार था, आपकी प्रेजेंटेशन बहुत अच्छी थी.
Maria, can you introduce you are from high tech?
I am from UT Texas, sir.
Yeah, UT Texas, because I contact last time we have communication.
Yes, sir.
Okay, so you are basically in mathematics?
Yes, sir.
Okay, there is a many. Okay. Anything you have in this seminar about mathematical modeling and mathematical problems, you can contact.
Okay, sir. Okay, thank you.
Thank you, Maria, for your feedback. Muhammad Noman.
Sir, I am Hamza from Prabhat University. Very good presentation, sir. Very informative presentation.
Thank you very much, Hamza. बहुत बहुत शुक्रिया. आप कौन सी डिसिप्लिन में आप?
Computer science, artificial intelligence, machine learning, डीप लर्निंग यूजिंग स्टिग्नोग्राफी और डीप लर्निंग पे काम कर रहे हैं।
Okay, awesome. जी प्लीज, कौन बात करना चाह रहा है?
मोहम्मद अमीन।
अस्सलाम वालेकुम।
अक्सा खान बोल रहे हैं जी। अक्सा प्लीज।
Yes, sir. You can hear me?
यस वी कैन।
Sir, sorry, इंटरनेट का इशू था इस वजह से।
जी प्लीज अक्सा, could you introduce yourself?
Sir, I was student of software engineering. Now I am the student of MS in AI.
At PFIST, right? Aksa, are you a student of PFIST?
Oh, yes, sir. She is.
Okay. Okay, good. Muhammad Amin. Muhammad Amin, please.
Assalamualaikum, sir.
Ji, walaikum assalam.
Sir, I am Amin Nadeem from Punjab district Toba Singh. In 2012, I completed MIT from Virtual University with my job. And in 2017, I completed MS Computer Science from University of South Asia, Lahore. And I recently working as control room in charge in Rescue 1122. So I really appreciate this session, and because I recently applied number of universities abroad, and I feel there are a lot of gaps in our education system. So these types of interactive sessions are really helpful for me.
That's very good. Amin, how did you learn about this seminar?
Might be I go through one of Facebook group scholarship network, and there someone shared this link.
Okay, okay. So please stay connected with our social media because we arrange these seminars on recurring basis every month or every once in 2 months. We seminar such kind of informative sessions. I think in the futures you could also learn a lot based on these seminars.
Recently, I apply one of the university in Italy. There ask me a question about human AI related. So I not respond as they have they need. So this is the these are the sessions we have conducted frequently because there are a lot of confusions in Pakistani students, and there are a lot of differences between foreign study and continuous study here in Pakistan.
Yes, at PFISC and SPCAI, this is our objective to bridge the gap as much as possible, what people are doing in developed countries and what students from the developing countries like Pakistan can learn from it. So this is one of the objectives of these government initiatives. We are a government funded agency, we are a government funded institute. So the government of Pakistan is actually working on the uplifting of socio-economic settings and knowledge barriers in the local community. So we hope that in the future you could also learn something more than that. But thank you very much.
So this is a nice initiative. Again, sir, one thing I point out here, I completed almost 120 courses from Coursera, and mostly I completed AI related specialization also. Thanks, sir.
Okay, बहुत शुक्रिया. Thank you very much.
Thank you. Thanks.
Okay.
Assalamualaikum, sir.
जी वालेकुम अस्सलाम. Ahmed, please introduce yourself.
Sorry, sir, my mic was disabled. I tried to respond.
It's okay. Please,
My
please
name is
go.
Mohammed Ahmed. My name is Mohammed Ahmed Khan. Intelligence at Pak Ashraf Fakakshale. So as my background is related to hardware field, this presentation was really interesting and attractive for me.
Okay, thank you very much, Ahmed. बहुत शुक्रिया.
Thanks.
Mohammed Noman. one? Can you hear us? Okay, we move to the next candidate participant. That is Muhammad Qasim. Qasim, can you please hear us?
Yes, sir, I can.
Okay, please
So,
introduce.
sir, I'm student of MSAI at PFIEST. As sir, meeting was very informative, and I want to join such kind of project which improve my hand-on experience on artificial intelligence and machine learning projects.
Okay, thank you very much. Tahir, Mr. Tahir.
Assalamu alaikum, sir.
Ji, walaikum assalam.
Actually, sir, my mic was disabled at that time, so that's why I can't able to speak. Actually, my name is Hamna, and I'm from the Department of Chemical and Energy Engineering. Well, I want to say about this seminar is that it increases my knowledge a lot because it is not related to my degree, but in order to get the diversity and to know about artificial intelligence more, it helped me a lot. So I really thank you.
Yeah, thank you very much, Amna. That's a nice feedback. This is the whole point, that how we can impart the knowledge among the people in Pakistan, and especially our PFIS student. So we are trying to arrange all these kind of seminars for your more educational purposes. So thank you very much for being with us today. And is there any other participant? Do you want to say something, Hamna?
No, sir.
Okay, thank you very much. Is there any other participant who would like to say anything before we formally conclude the session? Okay, so if there is no further comment or further question from the participant, then thank you very much, Dr. Maqbool. Thanks once again for your time
Thank
and
you.
giving this presentation. As we could hear from our participants, that brought something to their knowledge and they learned something out of it, and that is the whole point of conducting those seminars. Okay, Dr. Suhail, are you there with us?
Dr. Suhail.
Can you hear me, Dr. Suhail?
His mic is muted, Dr. Suhail.
Okay, maybe he's busy. But anyway, so thank you very much, and have a great weekend, everyone.
That's okay. I would also like thanks to all the participants for listening and joining me in the webinar, and thank you, Dr. Atif, and also the SPCI team for managing, and Ehsan and Dr. Suhail, Dr. Ihtisham, and other colleagues. So okay, thank you. See you next time.
Thank you very much for Hassan, actually.
Thank you, Dr. Maqbool. Thank you.
Who is all doing all kind of necessary technical stuff. So thank you very much, Hassan.
Thank you. Okay, Allah Hafiz.
Okay, Allah Hafiz. Bye-bye.
Allah Hafiz.